Okay, so welcome to class 6 of Big Data Analytics. As you can see, I'm adjusting the syllabus as we go along. So this week we should be about here, unsupervised learning. Now, last week we did cover what aspect of linear algebra and what aspect of calculus would be needed in this class. There's only one aspect of linear algebra that we didn't cover, I think, the major one that you will need. And let me just go ahead and address that gap real quick. Okay. Now, let me share the screen. Great. That's good. Okay, can you guys see now?
Yes, we can.
Yeah, okay, yeah, very good. Now let me go to this one. This is the worksheet, the workbook that I sent, I think 1 or 2 days after last class, and it has basically all the functionalities that you would tend to use to operate on linear algebra. Okay, like row reduce. It's a lot of stuff, transpose, identity matrix, inverse and stuff. But let's just look at the sort of like a summary of what you need to do. You need to be able to say, okay, this is a matrix. Now, you can see from the code that I put everything in matrix form so that it looks nice on the screen. It's easy to visualize. But again, when you work with the real computation, the real code, you just use list of lists. Yeah. So let me put that in the note. Okay. So remember, we work like this: A, B, comma, C, D. Okay. So that's a matrix, right? But if I want to make it look nice, I put matrix form. Okay. But if I want to use operation, I would just use it in the raw form. For example, if I want to multiply this matrix by a vector x1, x2, I would just do this. Yeah, right. Okay. So this is sort of like a summary table of the sort of object that you'll be working with. This is a matrix. This is x vector, right? This is ax. So this times that plus this times that, right on top. Now, obviously, you work with system of ax is equal to b. Okay, so this is how you solve ax equal to the right hand side 2, right? So when you solve this using Mathematica, it's very easy. Well, if you want to do this, just say x1, x2 equal to inverse of this matrix. Dot right hand side. Okay. Now mathematically, this is saying that if ax is equal to b, x is a vector now, then x is equal to a inverse b. Okay. Inverse. Yeah. That's that. Now a inverse is normally written as this. A shift enter -1. Yeah, so that's how. Now, what was the thing that I said just now that we haven't covered? What we haven't covered is this thing called eigensystem. Okay. Now, I'm going to give you a quick intuition of what an eigensystem is. Let me just show you this picture really quick. Very easy. And let's look at this picture. Now, if this is x, okay, this is x. This is everything is done in 2 dimensions. This is x vector, right? X vector is minus 0.8 and plus 1.6 or something. Okay. When you multiply x by the A matrix, you get the right-hand side, right? This is AX. You notice that 2 things happen. Yeah. This is a vector in 2 dimensions, minus 0.9 and 1.8 or something. Okay. And once I multiply by A, I get 0.4 and 0.6. Okay. If you are looking at this, what can you tell me happened? I transformed the line, red line, into the blue line. Yeah. There are 2 things that happen. 1, I rotate. 2, I shrink it by some factor, maybe like a third or something like that. So I make it smaller. So the length of this vector is smaller. Okay. So the red, so notice one, okay. So I say blue vector is equal to rotated and lengthened red vector. Okay. And so blue vector is B, and rotate and lengthen is A, and then red vector is X. Okay. That's what it means by a matrix operation. Okay. Now, can you imagine that? What if A is equal to identity matrix? If A is an identity matrix, what would happen? Anybody? If A is equal to 1, 0, and 0, 1, what would happen to the blue vector? Anybody? You should know this already. Nothing, right? Because the identity means it just leaves it where it is. So there are 2 actions that the matrix perform. One is to rotate, one is to lengthen or shorten. Okay. My question is this: if A does both, so A is not an identity matrix. A does both a rotated and lengthened shortened vector. Maybe I can find direction V such that A, B is equal to V except lengthen or shorten. Okay. So yeah. So normally AX is a rotated and shorten or lengthen X. Maybe I can find direction V. Okay. Right again. If A is identity matrix, then AX is equal to X. Nothing happened, right? So neither rotated nor lengthened. Okay. I'm gonna choose the different word now. I'm use the word stretch. Okay, because let's say you can stretch and shrink. Well, anyway, lengthen and shorten is fine. So, my question is, can I find a direction V such that when you multiply V by A, you get some kind of lengthen or shorten V, but not rotated. Okay. When we say that it's not rotated, it means it's the same direction. The German word for same is eigen. Okay. So we'll call this B eigen vector. Okay. And AB is equal to some multiplicative factor LV. Okay, follow me this. Can you follow? This is a matrix. This is a vector. This is a vector, but this is a scalar. So what happened is if AX is equal to a stretching action, you would do nothing in terms of rotation, but you would just stretching. You'd be stretching a line. Okay. So that is called eigenvector. Okay. And call this L eigenvalue and call AV is equal to LV eigen system. Okay. Now, some of you may have seen this already. Some of you may not. Okay. For those of you who have seen this, it's a review, right? For those of you who haven't seen this, the intuition is just this. Okay. For any vector, the red vector, I multiply by A and it rotates and shrink or maybe lengthen. But maybe I can find a sweet direction. You know, it's sort of like A is a modifier, it's a transformation. It's changing direction, it's changing the magnitude. It makes it longer, it makes it shorter. It can make it go negative even. So it can actually go the other way. Okay. So it can make it can transform the vector into any direction and in any magnitude. But what if we find a sweet direction and that direction doesn't rotate anymore? It just keeps going. It either gets longer or shorter or goes negative. So this thing is called eigensystem. Now I'm going to leave it at that because there's a whole this eigensystem is everywhere in data science. Okay, it's everywhere in data science. So in data science and data analytics. Okay, so this is a note on one more thing from linear or matrix algebra. Unique. Okay, so that's it. So now we're ready to go to upper machine learning. Okay. Now, you haven't actually seen how this is used in data science, but you will see later either in this class or next class. So I'm just going to leave it at that. Okay, just say eigensystem or eigencalculation is something you need. That's it. Okay. Notice from picture now. Okay, so that's it. That's one more thing you need from the matrix algebra that we didn't cover. And now we're ready to play with data. So have you downloaded these 3 sets of data? Okay. Assume you have. Assume you have. We are actually going to play with this one first. Okay? We're actually going to play with this one first. And let me show you where we are. Okay. We are doing, oops, where's the syllabus? There it is. Unsupervised learning set, item set, and cluster analysis. Okay, this is what we are going to do. Yeah. So we'll cover this thing first, half of the class, and we'll cover this thing in the second half of the class. Yeah. So item set. So what is item set? Well, we can actually Google things. Okay. Frequent item set. We can actually go to There's a lot of web page in in English and in Thai, okay, about things like association rule, frequent item set, a priori. Okay, you can find it's like a zillion pages. There's a 6 million page of frequent item set. Okay. What exactly does it do? What exactly does it do? So let's get a picture of supermarket basket. Okay, there you go. Okay, you guys see this? Okay. I'm still sharing this, right? Topcoder.com. Okay, so this is what's called a basket. Okay, a basket contains all kinds of items. This is grocery item. It contains oil. It contains bread, French bread, milk, eggs, right? So this is stuff that it contains. Okay, so you can think of it this way. You can think of it as, let me go to. My shopping basket is equal to, forget about number, just say what item is, egg and milk. Okay? And your shopping basket is equal to eggs and juice and okay, so may I do this? Okay, now this is my data. So now instead of my shopping basket, I would say my shopping basket 1 is this, and shopping basket 2 is this. Okay, right? So let's add a third person. Shopping basket 3 is equal to soda and veggies and cake. Let's call that. Okay. So now I have three baskets. Now, obviously, if I have 1,000 baskets, right, and this is my data set, okay, how would I store it? Well, obviously, I would not do it this way. I would instead do it this way. Shopping basket data is equal to this, right? Comma, and then comma. So basically, it's a list of lists, right? Right? So that's my shopping basket. Now notice, I can also put this in matrix form if you like. See? But does it work? No, it doesn't, because this thing has different dimension, right? In matrix form, you have to have the same number of row as the same number of column. In this case, you're trying to say something like, well, I have 3 rows of data, but in this case, I have 3 columns. In this case, I have 2. It doesn't really make sense, okay? But certainly you can put it in table form, okay? Because the table doesn't care. It's not a matrix, okay? So you can see that this is the first person, 3 items. Second person, 2 items. Third person happens to have 2 items. Yeah, that's not a problem. Yeah, let's make it more interesting. Let's cake and butter. And, yeah. Yeah. Okay. Now notice what happened. Okay. There are some items that appears in both baskets. Okay. right? You can also have some items that appear in all basket. Let's do this. But let's not put that in the same order. Let's say something like now. My question is, yeah, from your perspective, look at this. Does it really matter which one comes first? Does it matter? It doesn't really, right? Because basically you're buying everything. So, in other words, if you're talking about a list, is this thing the same thing as this? False. It's not, because this is item number 1, this is item number 2, this is item number 3. But in this case, you don't care. You want this thing to be equal. So you want to create a thing called basket object. Yeah, basket object. Now let's go look at our data set. Now let's assume you have already downloaded this data set, right? Okay. And oh, I haven't done it, so it takes me a while. See, that's why I asked. Okay, so this is it, right? And I set the notebook directory to the class, whatever it is. Okay, and then I export. Okay, that way I can look at it later. So you can see that, yeah. Now let's, because I should have put in CSV. It's gonna take a while because it's a large file. It's a large file, but it's not that large. You can still open it now. Okay, you see that it has a whole bunch of number. Yeah, so maybe I should, let me do this again. Sorry. CSV. Okay. Open it again. Okay, that's better. Okay, now watch. What does this mean? This means this is the first basket. Now, instead of using eggs and milks and soda, I would just use a number. So maybe egg is 1, and milk is 2, something like that. Yeah. So because a supermarket doesn't have just a few items, it has 1,000 of items. It's not sensible. It's not practical to use just the text. Somehow you have to have a number as well. So this means that, okay, these are the basket. Okay. Now let me make it a little bit larger. Okay. Now I want you to, by the way, repeat this step, because afterward you can hand this in as in-class assignment. Okay, so you download this data. Okay, download this data. You can export it. I happen to name it this way. You can name it however you like. Okay, so I just import from the internet, but because it takes a long time and my connection may be unstable, I don't want to lose this information, so I just download it for safekeeping as a CSV file. Okay, I can read this thing back again. It'd be the same thing, right? Now, because the data is quite small. What do you mean by small? Let's find out. Yeah, it's 88,162 basket. Okay, 80,000 basket, 90,000 basket. Okay, so this means that this data here, by the way, this data here is from research database on retail shopping basket in, I think, Belgium. Okay. Now, the reason I chose this one for you is because it's very small. Okay. In real life, the data is quite large. This is pretty small, pretty manageable. So what we are talking about here, is this guy. Sorry. Okay. Data 1 is equal to record of how many basket? 80,000 basket. Okay, 50,000 basket of grocery shopping in Belgium. Now, if you notice, the first line here is a little bit funny. Okay, well, let's look at this line. So this is one basket. Somebody went into the supermarket and bought item 30, 31, and 32. Another person walked in and bought item 33, 34, 35. Now, the first person didn't buy 0 up to whatever, 29. Well, could. Okay, could. Yeah, but this is kind of like a funny. Normally, you wouldn't see basket that looks like this, you know, from item. So, how many items are there? That's a different definition than how many basket, right? So, how many basket have we got? How many basket? We got this. Yeah, let's write that down. So, it's got. Oops. What's 88162. 88162 basket of grocery shopping. Okay. Now, there are how many different items that this grocery data set contains? In other words, if you saw our example, we have egg, milk, and bread. 3, 4, 5, 6, 7. We have just 7 items. We want to know how many items they have. The most obvious, yeah, what's the obvious thing to do? Well, if you happen to realize that all of this data, yeah, let's look at the data. Oops. The data looks like this, right? Looks like this. If you notice, all the numbers are in order. In other words, it's the item number from item number 0 to item number whatever, 2,000, 3,000. So if you ask how many items, number items is equal to, because it starts from 0, right? So you can say something like it's equal to max data plus 1. Yeah, you could say this. Okay. Now, is this a smart way of doing things? Well, it's almost smart, because you notice that the items are listed from 0, 1, 2, 3, 4, 5. But what if some numbers are skipped? Okay, there's no way you can eyeball this and say that maybe item 738 is missing. It's no longer in production. So what you want to do is count how many different items. And the easiest thing to do is use this function, count. Yeah, so this is not a smart way of doing things. So I'm going to erase that. smart way to do things is count. Now I'm gonna name this thing item frequency, and the reason will be shown. Okay. Okay. You can, let me show you. If I did this, count data, it's going to count number of unique basket. In other words, it's going to count the number of basket combinations. But what I don't want the number of unique basket. I want the item themselves. So the first thing I do is I flatten the data. Okay. By flattening the data, I'm throwing all the items together. Okay. Now, obviously, some of these can appear more than once, more than twice, right? You can see that this guy's 33 is here, 26 is here, 32 is here, 23, but it's also here. Okay. So what I want to do is flatten the data, then I count, and this is the result. Item frequency. What is this? Now I have to go to a side note, to data structure. We have Mathematica list, right? For example, my list equal to A, B, C. There's this thing called association. Okay, association. Natcap in Python it's called list, right? List is called list as well.
Oh, this is called list. Yes.
List is called list. In now Mathematica has this thing called my association. Association equal to, and the way you write it is funny bracket like this. Yeah, something like A point to 1, B point to 2, and C is point to 3. Now, what this means is that my association, if I type in my association and I give it A, it's not going to give the value A. It's going to give 1. Okay, this thing in Python, it's called dictionary, right?นะครับ.
Yes, it's called dictionary. Yes, it is.
Dictionary. Okay. So in Python, it's also list in Python. Yeah, but it's a dictionary. Now, this count object, okay, you notice it has this funny bracket, right? And it has this funny bracket to the right, and it has this arrow. What it's doing is giving the count. It's okay. So the count is the function. The count is the function, but it's giving you gives you an association between item ID and how often ID counts the ID item appear. Okay. So this thing here is going to give you a very easy way of doing things. Okay. Now, if you were to do this in say spreadsheet, you have to say flatten the file, order from smallest to largest, and count. Okay, so just to repeat, we have downloaded this data. This data is a list of a list. Okay. It's a list of individual record of a single basket of grocery. For example, this basket contains item designated ID from 0 to 29. Okay, happens to be in all 29 or 30 of them. The second person comes in and buys item 30, 31, 32. This person buys item 36, 37, 38, 39, 40, and up to 46. And somebody else buys 39, 41, 101, and so forth, right? So these are all different items in different baskets. How many baskets are there? Well, we find out, we just say length. So there are this many baskets. Now, I want to now count how often each item, not each basket, how often each unique item appears. So what I do is I use the function flatten. When I put flatten on this, it just lists everything, okay, like that, okay? So it's basically dumping all the basket, all the 80,000 basket into one gigantic basket. Now I'm going to count how often does 0 appear, how often does 1 appear, how often does 39 appear, how often does 146 appear, and so forth, right? So I do this and I use the word count. Okay, that's the function count. Okay, that's a function count gives you this. This, okay, this is a special data structure. Okay, it's a special data structure that has this kind of funny bracket and this kind of arrow. Hold on, let me turn off the commercial. Sorry, I left the thingy. Okay, so this is an association. Okay, an association, if I say, I want to know how item frequency, okay, I want to know how often does item 666 appear? 69 times. How often does item 0 appear? 117. Okay, right? Okay. Now, it's going to do this for every unique value. Okay. So if you make an assumption that the maximum value is 16,000 and it has all the product from 0 to 16,000, you would think that there are actually 16,000 products, but actually it's going to count all the unique number. This function count here, this function count, it's going to give you the unique ID. So if it's missing, it's not going to give a count. So if I do the length of this thing, length of item frequency, automatically gives you the number of unique product ID. Sometimes I'll use so think of basket of products. Okay, basket of products. Okay, so let's see what I get. Well, it's actually a little bit less. Okay, it's not as high as what's the maximum number? Maximum. Okay. Oh, okay. It's the same. So what this means is this data set is so nice. This data set is so nice. It's giving you all consecutive number. Okay? All consecutive number. So all the items are there. But this is not always the case. Okay, this is not always the case. For example, if I do this to my thing, okay, see that? This is my data. Okay, this is my basket. My list of baskets equal to this. Okay. right? And I'm going to say, okay, how many baskets? Okay. That's going to give you 3, obviously, right? But now I want to count the unique items. So what I'm going to do is flatten my list of basket. I get this, right? Now I'm going to apply count to it. Okay. It's going to say, oh, wait a minute, this is no good. This is giving you the order. Okay, this is giving you a sequence of, sorry, because I made a mistake. I should have done this. Yeah. There are 3 eggs, 2 milk, 1 bread, 1 juice, 1 soda. Okay. So how many of this? 7. Yes, obviously, because there's 1, 2, 3, 4, 5, 6, 7 products. Okay. Right now, I made a mistake because eggs has S. So same thing here. Same thing here. This is sort of like, okay, except you're doing with the, I want you to get a taste of working with the real data set. So this is relatively realistic data set. It's not as big as, say, if you were to analyze, big C supermarket. It's going to have millions of records. It's not going to have like 80,000. Okay. So there. So you have this many items. Okay. Now, would you like to see how often you get, various products? Now, here's an interesting thing. You have this thing called association. This thing is called an association or dictionary. Okay. So this is association. Dictionary in Python. Now, the dictionary or association is going to have an association between left and right. Left points to right. The left thing is what you use to identify. So it's actually thought of as a key. The right thing is like a values. So if I take this and I just want to list the keys. Okay. Notice, see, that's all the left-hand side. 0, 1, 2, 3, 4, 5, up to that many items. Okay. So there are 16,470 items because start with the name 1. Now, what about if I say values? Now, this values is going to give you all the right-hand side. That's the right-hand side. So if I want to know if a lot of items are bought, this item is very popular, right? This item 0 appears in 177 baskets. Some items, the higher number 1 are not that popular. So maybe appears in 1. So I want to know the histogram of this, right? So very easy. I just put histogram. Right? See? Now this histogram has 2 field buckets. I want to make it a little bit more detailed. Oops. Sorry. My bad. I want to make it a lot more detailed. So apparently this is not good. Okay, how about this? Okay, so it's giving a lot more finer. So again, this is like a number of bucket or number of basket. But again, most items appears once or twice. Sorry. Yeah, most items, okay, appear once or twice. There are very few items that appear maybe 50 times or more. And this number here, this 0 here is very popular. So it's among this, okay? it appears 177 times. Actually, we can do this. We can say, what's the maximum? Okay. So maximum value is, so there is actually one item here somewhere that appears, okay, in 50 basket, in 50,000 basket. So there's something all the way up here, okay, that you can't even see. Okay, so this is how you do this kind of breakdown. Okay, now this is where I'm going to teach you. Okay, let me write down what we've got so far. Okay, how many? Okay, use count, flatten, data 1. Frequent, item frequent, to get association, okay, from ID to its frequency. Yeah, how often? Frequency in this case means how often. Okay. Length. Note. Length of data 1 give number of basket in the record. Length of item frequency gives number of unique product IDs. Okay. And you can do something else. Okay. Okay. Length of flattened data gives number of items sold. All items sold. In this data set. Okay. Okay. So, and this is a note that I wrote you earlier, just to make sure you understand this association. Okay. Okay, good. So now let's do a little bit of analysis. Okay. Let's do a little bit of analysis. What is actually a basket analysis? Well, we can search. We can find some kind of. Okay. Just Google basket analysis. Okay. Yeah. Better yet, use the word market basket. And sometimes they like to make funny acronym like MBA. Okay. So there are 1,000 pages on this, 1,000,000 pages. Okay. Yeah, almost 1,000,000 pages. Okay. So what does it do? What does it do? By analyzing the data, by analyzing the market basket data, okay, what you can get insight into, what kind of insight can you get into? Okay, so forget about analytics for now. Just say if you have this question, if you have this data set, okay, before we do any kind of filtering or analysis, what do you think you can? What questions do you think you can ask? Well, I'll list a few, right? Which items are most popular? Okay. On average, how many different items do people buy? Okay. Okay. So which item is the most popular? So you find the one that has the maximum. On average, how many different items do people buy? On different items do people buy? So let's go back to this. Okay, so instead of doing the histogram, you just do a mean. Okay. Oops. Okay. On average, okay, on average, it's 55 items. 55 items. Okay. Why does it not look like the right average? It's because there are some baskets that are, you know, really huge. So maybe it's a wholesale buyer or something like that, and that sort of like shift the balance. But definitely, if you put a sort of like a little wedge at 55 here, this data histogram will balance. Yeah, balance, not fall. Okay, so you can do this. Now, obviously, these are something you can answer right away. But what basket analysis is family or collection of queries like this, like the above, except more useful for marketing planning purpose. What do I mean by that? What do I mean by that? Well, certainly this is which item is most popular. That's also useful for marketing. Okay, so this is useful for marketing. Okay. On average, how many items do people buy? Well, that's also useful. Why? Because you might think that, you know, if people like to buy a lot of different items, we can make the basket bigger, so people will buy even more, something like that. But what they tend to do is some kind of association. Now, I don't mean association as in Mathematica data structure. I mean, quote unquote, correlation. Okay. The reason I have to put in quote is because correlation has a statistical definition. So when people buy milk, they also tend to buy, say, egg. So this is kind of probabilistic thing. Okay. So if you ask, okay, when people buy milk, do they also buy eggs? Yeah, that's the question. Okay. The way this is asked is that, okay, let's do statistics. Okay, statistics looks like this. Okay, let's go to statistics. Okay, there's a probability of, I'm gonna omit the word buy. I'm just gonna say milk. Okay, there's a probability eggs. Okay. Now, let me put this like this. Statistic data. Okay. So data would be what? Number of basket with milk divided by all basket total. Okay. Same here, probability of eggs. Now, what else can I do with statistics? I can do this. And together. Now this is a basket. This, what's the difference between this basket here and this basket here? Anybody? Yeah. The difference is that this is actual basket. This is actual basket. Okay, this is actual basket. This is what people actually bought. This is a hypothetical basket. Okay, probability of milks and eggs. But this is actually not what you are interested in. You know why? Because if you want to know milks and eggs together, you don't want just this basket. You want probability of milk and basket and etc., etc., etc. Okay. So in other words, it's not probability. Okay, this is one probability. It's not what you want. What you want is probability that the basket contain this. So it's, which is equal to probability of this alone plus probability of this and bread plus dot, 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 dot. Okay. In other words, you're not just counting you're not just counting to be of interest milk and eggs. Any basket that contains milk and egg, yeah, it may contain just milk and egg, fine. But even if it contains something else, you still want to count it. Okay, and so this market, okay, this market basket analysis is when you have all this kind of thing. Okay. Hypothetical question. So you don't want this, and this is how you use the market basket analysis. Now let me put a note in here, okay, just so you know. In practice, there's an efficient library called a priori, for instance. Okay, a priori algorithm. Okay. Okay, in practice, you would do this. So today, I think I would like to start a conversation about your project. So some of you might want to do this. Okay, might want to do this as your project. So that's basically what the algorithm is going to do. It's going to ask, basically, it's going to ask this kind of question. Okay. Let me add more questions. So it's not just one question or one analysis. Okay, like asking for distribution. It's going to ask for a lot of things. or something like, now this is interesting. You ask this, you can say probability, okay, basket contains milk given basket contain bread, or let's say bread, it's eggs. Okay, why is this useful? Why is this useful? Okay, now pay attention to this, and this is something you're going to find, you're going to be able to experiment in real life. Let's just say that very high. Assume you found this to be very high. Okay, what would the marketing people do? Grocery manager plan. Okay, plan. Yeah. Well, let's say that milk is fixed. Let's say milk has to be refrigerated. This is to be kept in a fridge. Say in the back left corner. Okay. Guess what they're going to do? Where would grocery manager put eggs? Okay. Okay. So given that somebody already bought milk, that person would also like to buy eggs. I ask you a question then, where would you put this? Well, there are actually two answers. A, put eggs close to milk to make life easy for customer. Yeah. If this were the answer, today when you go back to your dorm, before you go back to your dorm or whatever, stop by a grocery, see if milk and eggs are close to each other. Okay. On the other hand, they can say B, put eggs far from milk to force customer to browse through extra stuff. In other words, because they do this basket analysis and they say that given that the person buys milk, it's a high probability that this person will also buy egg. Instead of putting them close together, because it's convenient, you put them far apart, because if eggs is in the back left corner, okay, e.g. milk, eggs in say front right corner, guarantee customer will take a long walk, and therefore most likely, okay, and therefore more likely to buy other things. Okay. kind of thing. So it's you know, you can apply this principle to anything. You will notice that sometime you enter here, okay, you want to buy something quick and go to a toilet, okay, you have to walk like 500 meters from drinks shop to toilet. Okay. In the meantime, you know, because they may realize in this case it's not a basket of items to buy, but people who buy drinks and people who uses toilets, you know, there's a high probability that you would use toilets if you bought lots of drinks, something like that. So you see this everywhere. So this is called consumer manipulation. Okay, and this is done all the time. Okay. Now, you can't blame that as a priori algorithm for this. Okay, it's just mathematics. It's how they use it. It's just how they use it. Okay, so for example, now, so let's play with mini version of market basket analysis. So first of all, you know, you can use this sort function. Now, this is a little bit hard to wrap your head around, but maybe you can sort of like memorize it. This item here, this item, frequent item set here, okay, is this, right? It's this guy. Okay, it's this guy. Now, if I do this, okay, I sort. Okay, I sort frequent item set. Okay. Now, this thing is going to ask for what's called a pure function. But just forget about concept of pure function. I did point to some of you that pure function is very efficient. Well, this is one of the way it is efficient. It's like a database query. It's saying that if the one that appears first is greater than the second, so basically you want to sort in decreasing order. Okay. Now, what it's going to do, it's going to decrease by default. It's going to decrease on the values. So remember this thing I asked you earlier? What's the maximum of values item set? Okay, there's one item here that appears in 50,000 out of 80,000 baskets, maybe in 2/3 of buying stuff. Okay, but which one is that? Well, if you actually do this sort, you find out that it's item 39 because it's sorting from descending order. Okay. Now, if you did this, you get something else. This is decreasing order. Okay, I don't want that. So this is the condition. So I'm going to write this. Okay. Sorts item frequency in order of decreasing frequency. Okay. So now you can ask, what is your most popular object, right? The top 5. Maybe you just take the top 5. So, and then you can do something else. Okay. This thing, okay, this is sort, right? Sort. It means that you are reordering, but you're not eliminating anybody. Another function is select. Let's say that I don't want to focus on this low sale item. Okay. These low sale items are not really interesting to me. Okay. And I might just get rid of them. So I'm going to say item with frequency over 1,000. It's not sorted, but it's selecting a few. By the way, how many of them are there? So this function here, oops, sorry, select only items with frequency greater than equal to 1000. Yeah. You can do all kind of stuff. Okay, you can add many condition, greater than 3000 but less than 2000 or whatever. And this is all detailed. So if you go to select, you go to F1, you go to a help page. Okay, and it gives you all kinds of example. Yeah, select even number, select all kind of stuff. Okay, so this is something you can look at later. You can use in your project. Okay, so let's do this. Okay, so now I have, my question is, how many items? How many items? Well, how many items? 56 items. There are only 56 items. Okay, there's only 56 items. So let's look at the histogram of these guys. Yeah. Let's make it a little bit more details. No. I like to, now, not obviously, you have 200 buckets, you only have 56 value. Some buckets are going to be empty. Okay. So you see, there's some items to the right that's kind of like that, not shown here. So most items, again, start from 1000. You don't start from 0 anymore. So this is 1100 or something like that. I think 1200. And this is 3000. So this is just checking. Okay, this is checking logic. Sometimes I put this in for your benefit. You can say that you can sort items from highest to lowest, but the top 1000, or okay, you already get this one and then you sort. Okay, so it's the same list. This is the same thing. Okay. So whether or not you select from smallest, from largest to smallest and take the first 10,000 of them, or you take only those that are bigger than 1000 and sort them. Same thing. Now, I want to focus now again. I want to take the most frequent item. So I do exactly the same thing, except instead of taking the value, I take the keys. So this is the key. So it's like this list, except I'm just looking at the keys. Okay, and I'm just looking at 5 of them. So those are the guys, 32, 38. Say I want to focus on this guy. Okay, I want to do this guy. Now, watch this. If I want to find hypothetical, hypothetical baskets containing, say, A, B, C. Okay, what I'm going to do is, well, what can those baskets be? Well, it can be A, it can be A and B, right? And it can be A and C. And it can also be B and C. And it can also be A, B, C. Okay. Now, what are these? These are combinatorial. There is a function called subset. Now, subset of this will give you all this. Actually, it's going to give you one more. It's going to give you an empty set. Now, from high school arithmetic, you will recognize that this is the same thing as, in other words, subset of some kind of set gives power set of A. Okay. Okay. So let's see if that's true. Okay. So my basket item, so I want to do some kind of combination, right? So I just do this. I take this, okay, and I just calculate. So it has obviously a lot more. By the way, how many items are here? 2 to the 5, right? Because this is whether or not yes, no, yes, no, yes, no, yes, no, yes, no. 2 to the 5. What's 2 to the 5? 32. So let's see if this is true. Length 32, right? But unfortunately, well, not unfortunately, it just happens that you don't care about this guy, right? You don't care about the empty set. So maybe you don't care about single. You want to look at something like this. Yeah, you can look at single. So let's say I just want to look at 2 baskets or more. So let's say I'm going to take from 7 elements. Yeah. Now, okay, now I want to see how often each of these appear. So I'm not counting 32 and 38. I'm going to count every cases where 32 and 38 appears. So this, to make long story short, what I do is I flatten the data, I perform the counts, I sort from lower to higher so that it's always from less to higher, and then, okay, oops. Oh, okay. This is no longer true because I didn't. Okay, if I original problem was like this. Okay, so this is true. Okay. Now, but in this case, I don't want. I just want more interesting case. So basket. Let's do this. Let's do this. Sorry. Let's say basket item frequent top 5. Okay. 2 or more. Okay. With top 5 most frequent items. Okay, so these are out the basket. 2 or more. Okay, with top 5 most frequent items. So this is it. Okay, so it's less than 32. So this is what I'm interested in. Say I'm interested in this guy. Okay. Now what I'm going to do is I'm going to do this kind of frequency count. Well, you know what? Sorry. My code was already written in this. So let's take all the single as well. So some people just buy one item. Yeah, so take that. So don't have to rewrite all the codes. Okay, this thing is called sequence count. Yeah, it's not counting appearance. It's counting matching the sequence. Okay. Now, the
Professor,
sequence
if I
count.
could go slower.
Oh, sorry, sorry. I will give this to you, by the way, so you can look at. Basically, let's do this, and let me show you. Okay. Now, my data. Okay. Let's go to F1. Okay. This is the function I want. So it's basically looking at this list. Okay. And asking how many times this sequence occur. In this case, you can see that AB, AB, and AB occurs 3 times. Okay. So my question is, I'm gonna flatten the data. Yeah. So I throw everything all together, and I know that each basket would have an order from left to right. Okay. I want to say sequence count of this, and I want to, let's say, check how many times this thing occurs. Okay. This particular sequence occurs 1,752 times. In other words, in the original, you see this time, you would see it like this. Sometimes you would see it like this. Okay. Sometimes you would see it like, okay, like that. Okay. The point is that in order sequence, once you flatten the data, it's all in, just throwing everything together. It searches for sequence matching this. How many times does it match? It matches once, matches twice, matches 3 times. Okay. Now, all I'm doing here, okay, and you can check this, all I'm doing here is to make a table for all this. Okay. So this thing, 32 appears how many times? This many times. And the basket that we were concerned about, what was it? 1, 2, 3. Let's say we're concerned with 32 and 48. Okay. How many times does it happen? Okay. It's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th answer, 1, 2, 3, 7, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1884. See, that's true.
Professor, for the count, does it have to be in that order? Like
yes,
in the
yes. It's count sequence. Now, you have to realize, and I'll tell you why. In Mathematica, a list is an ordered collection of objects. Okay, so that's why if I try to find this, I would find. But if I try to find this, say reverse order, 40, 48, okay, and 48, 41, 33, 48, 41, 38. I don't find any. Okay, now because this has more information. Than unordered collection of objects. Now it turns out that in this particular application, you don't care about order. Okay, so But most of the application in data analysis, you would care about the order. And in fact, if you go into details of the a priori algorithm, it's working off of, I think, an ordered list. Okay, it does care, but you know. Okay, so let's do this again. One second. Okay, so this appears 243 times, and that's this number. Now, I haven't taught you how to use this map notation yet, but it's very useful. I'm gonna skip that. So I turned this into a basket association. This is just a function that turned this into a basket, the same way that the count, because the count is more obvious that what you want. It already gives you the association form. So in this case, okay, this is an example. Let's say if I want to know if this is my promoted basket, okay, I can say that this basket appears 243 times, okay, and I can do all kind of stuff. So, okay, so with just this, I can do again histogram. Well, we can do the values of this. Okay, oops. Okay, so there are various baskets. Some basket occurs. So the top most individually frequent item, and then you create a basket out of that. So this is how in real life you would do this. Now let me just tell you what I did. Okay, from experience. Okay, say this was at SCB. Okay, we use this. We literally use this because a basket is defined as items of category. Okay, category of items. Okay, that SCB Visa card holder is defined. Visa card holder bought over a period, say 1 month. Okay. Now this means that this here will be the basis of association between, for example, probability person buying gas. Okay, let's say by probability restaurant, say something like that. Okay, given, okay, or something like this. Better yet, movies, even restaurant. Okay, now something like this. Obviously, SCB is in the Visa card business, so they want to maximize Visa. SCB wants to maximize SCB Visa card transaction, right? Now, SCB cannot, okay, move, okay, movies far from restaurant, right? That's not what we can do, okay? But what we can do is use this information. For example, for example, if we know that if we knew that this is high, but could be higher, SCB can offer some kind of campaign, right? Say something like use SCB Visa to buy ad for say 1,000 baht or more at restaurant and get use receipt okay to get 10% off 5% movie price movies ticket for 4%, something like that. Okay, so you can see that all this here, you get a lot of this, by the way. I don't know if you have credit cards, but say if your parents have allow you to have credit cards, maybe you get a lot of promotion. That's where this thing comes from. Okay, now not only did we do this kind of association within 1 month, we also did what's called sequence, i.e. something like a restaurant in the second week of month for probability okay, so probability that you would repeat, right? If you promote a second week of, if you like the restaurant, you would like to repeat. So maybe in this case, promote early, okay, or something like that, or maybe end of month, or all kind of stuff. I mean, yeah, the detail is endless. If you're gonna do a project in this, then obviously you see a lot of that. Okay, so this is something so this is actually real work. I'm gonna erase that. Okay. So this is
Excuse
something
me.
that's
Let me break the recording.
Okay, good.
Just a sec.